Okay, today is a review day for vectors test. This is chapter 19. This is the last test. So, first, I started the kids off by giving them 2 points, and I have them in my room in a giant 3D matrix where we have a point at -2, 1, and -1, and we have another dot, a pink ball, at 1, 1, and 3. And I asked them to figure out what vectors they represented. So this is the yellow vector and the pink vector. So that means that they started at 0, 0 and went to this spot. And yet you don't need to write it this way. X, Y, Z with 0, 0, 0 plus -2, 1, -1. But you could if you wanted to. So anyway, that's two different vectors. And then I asked them to find the angle between them. So right now they're just wrapping up that part. How many guys have finished already? All right, good. That's the vast majority. Let's continue. Dice of Destiny. Who should I call on to give me some help here? Row 2, second person. That's you. Tell me the formula. A dot B. And I'm going to change that to Y dot P just because we have yellow and pink, right? Okay, equals. That's called magnitude. Very good. Very good. All right, and we don't know the angle. That's the point, so we leave it as theta. And at the end, we'll have to do inverse cosine to finish that off. All right, you gave me the formula. Let's see who's going to take the next step. Row 4, last person. What do you think? Any part of it that you want.
Okay, so for the dot product,
times that, -2, 1, -3, put them together, you get
-2, 1, -3, and you add
-4. Raise your hand if your dot product was -4. Okay, good. And then the magnitude of y and the magnitude of p. How do you get a magnitude for the kid that's like, I don't remember magnitude? I know it's square root of something, but square root of what, and what? What do you do with them? 2 squared, 1 squared, -1 squared. All right, so that's 4, 1, and 1. Square root of 6, and the other one comes out to square root of what? 11, and I had people ask me, can you put those together and say root 66? Yes. And it's also a famous road, Route 66. I don't know if you've heard of it. It doesn't mean root, R-O-O-T, it's R-O-U-T-E, but Route 66 is a classic old highway that goes through a lot of cool places. All right. And then your final answer would be -4 divided by root 66 equals cosine theta. And then you can just do inverse cosine. And let's see what this group got. It's row 6, last person. What'd you guys get? Final answer for inverse cosine. 119.5. Can anybody verify that number? All right, good. All right. Now, here's the next part. That was these two vectors where the ball that you have in the room was just like the end of a vector. What if we made a vector that started at the yellow one and went to the pink one? All right, that's a big task all in itself. And then in a moment, I'll remind you how to make that into a unit vector, which wouldn't be like, it looks to me like they're about 7 feet or 6 feet apart right now. A unit vector would only be 1 foot long. We always scale it down to only be 1. But to start with, you need to know what's the equation for the vector that goes from the yellow to the pink. Go. I'll pause while you figure that one out. The vector that goes from the yellow to the pink. Okay, so we're making the equation for these two, and it starts here, which makes it obvious what to put there. How do you get these numbers? Where did you get them from? All right. And if you just want to think through how do I get from here to there, that will work. Another way to do it is just a simple mechanical subtraction. Head minus tail. 1 minus -2, which means 1 minus negative means plus 2 makes 3. And then what did you say the other ones were? You got it. Raise your hand if you had that one right. Okay, good. Now, You can see that vector in the room here, right? It's going like this. And the ruler would need to be longer to be actually have the right magnitude, right? Would you now figure out the magnitude of this vector? How many feet apart are they? This is approximate, of course, but hopefully you know which part tells you that. Figure out the magnitude. I'll pause while you do that. Okay, to do magnitude, it's just how long is this vector? Well, we know it traveled 3 in the one direction, 0 in the other, and 4 in the last direction. And you can go a squared plus b squared equals c squared, except in 3 dimensions. So it's the square root of a squared plus b squared plus c squared, which is 9 plus 0 plus 4 squared is 16. Did you get square root of 25? Which is about 5 feet. Does that look like it's believable that it could be about 5 feet? Okay, so that vector right there is about 5 feet long. And now my next question is, what if I wanted it to be 21 feet long? Now, it'd be great if it was just like, oh, so times it by whatever. First, you want to make a unit vector. Everybody try to remember how to make the unit vector for this vector right here. Remember, that's not a vector. That's not a vector. The green thing, that is the vector. Try to remember how to make the unit vector for it. Okay. Magnitude of this guy was 5. We got that by square root of 3 squared, 0 squared, 4 squared. So what do we do with that magnitude of 5? Well, first of all, we want to shrink this vector, which is 304, down to be less than its current size, which is a current size of 5. So we multiply it by 1 over that. 1 over the magnitude. Raise your hand if you had that one right. Good. You don't actually have to multiply that out. You can leave it that way, and I'm fine with that. Next, let's say that I wanted this thing to be 21 feet long, did I say? All right, so then that's the unit vector. So I just take it and times by 21. It was only 1 foot long when I made it a unit vector, and then I just times it by however long I want it to be. If I want it to be 68 feet long, I times this by 68. All right, so the unit vector is handy because it can help you scale things up. All right, next concept. This equation form of my vector is the vector form of a line. It's a line that does not go between these 2 points. It starts at this point, and its directions on where to go are that. So that's like its slope. It is just like slope in the old days. Here's the old days, blast from the past. Y equals 3x plus 5. Do you get my slope is the directions on where to go. You start at 5 and you go 3 up and over 1. Technically, it's 2 directions because it's rise over run. Does that ring a bell? Okay, this has just got 3 directions. It's saying start here and then go this in this direction and that and that. So it's like a slope. It's up to a little more complicated. Okay, so then take a wild guess what the equation would be for something parallel to it. It would probably have the same slope. All right, so now here's the next level question. What if it's parallel to it, but it has to go through, or I'm going to say parallel to this, going through the point 1, 2, 7. I'm going to pause for a second. Write me the equation. Don't overthink it. This is not super hard, but I think only half of you will know right away. Parallel to that one, going through 1, 2, 7. Okay, if you took any longer than that, you probably didn't know what I was talking about. X, Y, Z, and the point that it's going through, well, if I want it to go through this, might as well make it start with that. That means it'll go through it, right? And then it's got to have the same slope, so I just use, I could have used t or lambda or mu or anything, but this has to be 3, 0, 4. Now it's got the same slope. Do you remember how if they're perpendicular, they definitely don't have the same slope? And do you remember that it was not just like the old days where you could make it opposite reciprocals to get things that are perpendicular? This was more complicated. It wasn't super complicated. It was based on, I want it to have a 90-degree angle, right? So we went back to this formula, A, B, this is dot product. except we knew theta. What was theta? And then, what's cosine theta? And if cosine theta is 0, this whole side's 0. And that means what's 0? The dot product. The A dot B has to be 0 if they are perpendicular. So, back to this guy. Once again, we have this equation, going back to this one. And this time, I don't want you to find something parallel to it. That's just using the same slope or the same direction vector. But I want you to find one that's perpendicular to it. But I'm going to give you this hint. I want you to use 2, 0, and something for your equation. So in other words, I only am going to let you change the n there. And this equation needs to be perpendicular to the other one. Make the green one be perpendicular to a blue one here. What does n have to be? I will pause for a second. I suggest writing an equation instead of just guessing and checking. Okay, here's the plan. First of all, I think you know the dot product's supposed to be 0, right? So what you do is set up 3 times 2 makes 6, plus 0 times 0 makes 0, plus 4 times n makes 4n, must equal 0. And if you can't solve that, we got to move you back a couple notches here. Subtract 6, divide by 4, 6/4, except it's negative. And we should probably reduce it. So final answer, sir? Mm-hmm. All right. And if you want to say it as a fraction, I agree with you, but -3/2. Either one is okay. So that's what n has to be. Raise your hand if you had that one right. Okay, good. Now, this one sounds weird at first, but I want something going in the same direction as this vector I keep coming back to. Except I want it to be 10 meters long. Any vector. I don't care where it starts, but I want it to be going in the same direction as this blue vector here, this guy. Same direction as this, but 10 meters long. Can't just take this vector and times it by 10. It won't be quite that easy. Any vector that's going in the same direction but is 10 meters long. I agree. We should find the magnitude first. And what was the magnitude? Cut to the chase. I'm not sure that's the magnitude. I think it's 3 squared and 0 squared and 4 squared. 9 and 16 squared to 25. So it's just 5. The magnitude is 5. Okay, it's all right. Everybody makes a math mistake every now and then. So if the magnitude's 5, given that, now what would you do?
1 over that.
1 over that times this vector. And then times that by 10. Now, do you get, if that's timesing it by 10, it's really like 10 over 5, which is like 2 times the original. So if you wrote 2 times 304, that works. Or you could have 608, for example. All right. Now, this would have been an okay answer because it's got the unit vector part, and it's just times by 10. How do I know it goes in the same direction? Because I use the same vector for its directions. All right. Next, something we haven't done in a long time. Drawing pictures like this. A, B, C, D. Now, I want you to see if you can draw AB. No, actually, let's make it DB vector plus BC, and then I'd like you to show me the difference between DB plus BC and DB minus BC. I'm going to pause while you draw those vectors. Okay, here's the quick answer. That plus that. And that's the wrong answer. Why? Because it didn't actually draw the resultant. Remember, the answer is a vector that goes from here to here. And so if you wrote DC, that would have been a good way to say it. Or if you drew that green arrow in, that is the resultant. That's the answer. Okay? Yes? Because it goes from where it started to where it ended. So think of it as like this is a long way to go. This walk went from here and then it went down here. That was the long way to get there. And you are going to start in the same spot and take the shortcut. All right, now how about the other one? The other one was the opposite direction of BC. That's what this means. This minus means go the opposite direction of. So now it doesn't go this way. This part is not correct anymore. Now it's here to here, and then it goes the opposite direction like that. So the resultant is this blue arrow up here. And I can't make it the right length because it goes off my screen, but I think you get the idea. All right. Now, what if we extend that, excuse me, that idea to points? We do agree if I put a big XY chart up here, or a big X and Y axis, that point A could be like 3, 12. And point B could be at like 8, 12. And then point C could be at 6, maybe like 8. There we go. Now, I'd like you to show me with column vectors. I don't need you to draw me a picture, but I would like to know what DB plus BC is now that you have the column vectors for it. I'll pause for a moment while you try to add those two. All right, you know what? I think we could probably assume this, but let's all agree on what D would be. Okay, because do you agree this one moved back a couple points, you know what I mean, a couple spots, and therefore, what were you guys thinking this point was? 1, 8. Let's all agree that that point is 1, 8. Okay? Because I didn't ever say that it was a parallelogram, and therefore you couldn't assume that, but I'll tell you it's 1, 8. Okay, let's see if you got what's going on here. I'm adding DB. Well, what is DB? DB is a vector. Now, I could write it out with its point it starts at and all that, but really the vector part is just the directions to get from here to here, just the directions part. Again, you can write it out with X, Y, Z and the starting point, but you don't really need all that. That vector is, well, what are the directions to get from there to there? I got to go how far to the right? 7. How far up to get from D to B? To get from here to here, you go up how far? All right, so there's 7, 4 is the original, okay? And then I add BC to that. What is BC's? It's like from here to here. Would you agree BC is head minus tails, probably the fast way to do it. 6 minus 8, negative 2. 8 minus 12, negative 4. Do you agree it went 2 to the left and down 4? Does that make sense? Negative 2, negative 4. And now what did I ask you to do? Add them. So 7 plus negative 2 makes 5. And 4 plus negative 4 makes 0. 5, 0 is the answer. You might have got it a different way. Raise your hand if you had 5, 0. Okay, good. Do you get, I could have just said what the resultant is, which is this, and then said what that vector is. That vector right there is over 5 and up 0, so that would have been another good way to do it. Okay, so that covers a lot of stuff. I would not go home and say, I feel ready for this test. I would go home and study for this test. It's your last big test, and there's no retakes for it. If that's added incentive to do a little studying, that might be smart to do. All right, so in the case of a tragic failure, if a kid comes in and does corrections, we might be able to adjust your grade a little bit, but I'm not going to like go from a C to an A because you come in and do correction problems with me. But if you have a tragic failure, we'll have something for you, but it won't be a simple retake where you get to get a higher grade. You might get a little bit of a bump for doing a lot of extra work. So I just do the extra work tonight. Study. All right. So your homework for tonight, I'm going to recommend, could you shut that door for me, please? I'm going to recommend that you finish that green packet. There's answers posted for it. And that's one of the best things you can do is do hard problems and check them and make sure that you're doing them right. Number 2, don't get all depressed because the green sheet is more difficult than the average, assignments. Okay, and if you need to, go back and rewatch the video that I'm recording right now. Because believe it or not, if you were distracted during this hour, you might get more out of it than you got the first time. Maybe doing them the problems the second time, you'd be like, oh, okay, I get this now. The other thing is not yesterday. Well, yesterday's video wasn't terrible, but it was mostly just about finding things that are perpendicular. But the day before that, I did some other good stuff, especially about 2 vectors that cross. Do you remember what I'm talking about? I am not going to go through and do a whole nother set of problems on how you tell if 2 vectors cross. Your job to go home and make sure you know how to do that. Okay? So if I gave you 2 vectors like this, no, not, I would have a number there. And I gave you another vector. I'll make it green. Would you know how to tell where these 2 vectors cross? We did it multiple times. I want to just get a summary. The first step would be to write them in what form? Parametric form. That means you've got an x equation for the blue one and an x equation for the green one. What do you do to them? Set them equal to each other. Okay? Once you set them equal to each other, you won't be done, but you'll have one of your system of equations. Then you'll write the parametrics for the blue one for the y and the green one for the y, and you got those 2 equations. You set them equal. All right. And again, I did do a lot of practice of those. If you want to go back and watch an old video of that, you are welcome to do that. But I felt like if I do that again, it'll be boring to the kids who were paying attention the first time. Okay, and if you don't get how to do that kind, I would strongly recommend you go back and review that. Okay? Let me just ask you a couple like simple questions to follow up on it though. Let's say I told you that when I solve this thing, lambda, and let's say I do a different lambda, I'd say I do a t, just so I can talk about them differently. Lambda and t both were 3. What would that tell you? That they did intersect. Did that mean they were there at the same time also? Yes, and that means not only did they intersect, they collided. All right, then what if t was 5 and lambda was 1? Did they intersect? If they were at different times, did they intersect? Yes. Did they collide? No. Okay. And then lastly, let's say that time, I'll keep it really simple. Let's say time was 1. P was 1. Where these guys intersected, if t was 1, I want you and your partner to figure out where do the lines intersect. If t equaled 1 when you were done solving, what does that mean? I'm going to pause while you try that one. All right, so if you put in a t is 1, you just put a 1 right there. And then it's 4 plus 1 times negative 1, which is 4 minus 1, which is 3. Raise your hand if you had 3 as their intersection point. And then 1 plus 1 times 0, which is just 1. And then 7 plus 1 times 3, which is 10. 3, 1, 10 is where their paths intersected. But again, if this lambda was 5, that would imply, and again, these do not actually intersect. I did not make these to intersect. But if I was saying that my results were that this was a 5 and this was a 1, then you would want to double check that they actually went through the same spot. And again, if you actually try this right now, these would not give you the same point as that. But times being different means they were going in the same spot, but at a different time. All right. And again, the blue one and the green one here actually in the real world would not have intersected. That would have meant when you actually went through the process, it would have failed. And it would have like not given you an answer, no solution. That means that your vectors never crossed. Okay. All right. So again, I do recommend that you go back and make sure you know how to do that. I think there's going to be plenty, if you could look back in the old homework, plenty of problems that you could do that talk about these two planes intersecting at this point, and there's even answer keys put up. So if you decide not to review that, that's on you. All right. That's all I have for you for the review for today. See ya.